So today we are starting our unit 4, on parallel lines. So this is unit 4, day 1. So if you want to start your notes, unit 4, day 1. All right. So we're going to talk about a lot of properties that involve parallel lines. And when we have parallel lines, that creates a lot of relationships between some angles. So we're going to focus a lot in this unit on the relationships that parallel lines create. All right. So parallel lines, we know what parallel lines are from Algebra 1, right? They're two lines that never do what? Intersect. In Algebra 1, what did we also learn about parallel lines? They had the same what? Slope. Very good. So they're two lines that have the same slope and they do not intersect. And here in geometry, we also learned they are also coplanar. What does that mean, coplanar? They're going to be in the same plane. So parallel lines are not going to be like on two separate pieces of paper. Okay? So there's not going to be a line. Yeah, if I have a line on this page and a line on this page, they're not going to intersect, right? But it doesn't matter because they're not coplanar. So I wouldn't call those parallel lines. All right. So skew lines are lines that don't intersect and are not coplanar. So that means they're lines that don't intersect, but they're not in the same plane. Okay, so that'd be like a line over here and a line over here. All right. So skew lines do not intersect and they're not coplanar. And then parallel planes are two planes that never cross each other. So that would be like if I were to hold these pieces of paper like on top of each other like this, but don't touch them, right? Does that make sense? Or like this, or like this, or like this, or whatever. So parallel planes are two planes that never cross. All right, so we want to know those definitions. All right, don't write down this one. It is on your handout I just gave you. I believe it's the very first one. Parallel postulate. The parallel postulate says if there is a line, highlight it. Yeah, let's highlight them as we go through them so that way we know which ones we've covered. If there is a line and a point that's not on the line, then there is exactly one line through the point that is parallel to another line. Okay, so a parallel postulate says if I have a line and I have a point, then we can draw a line through that point and it be parallel to the other line. Okay, that's the parallel postulate. All right, perpendicular postulate says the same thing except for perpendicular lines. Now, what's a perpendicular line? What are lines that are perpendicular to? Right angles. They intersect and they form right angles when they intersect. So the perpendicular postulate says if we have a line and we have a point that's not on that line, then there is exactly one line through the point that makes a line that's perpendicular to the given line. Okay, so that is the perpendicular postulate. So you can highlight that one as well on your handout. All right. So let's talk about some angle relationships. First, we got to talk about a definition right here. Transversal. Please copy down this definition. It's an important word. A transversal. You're going to hear me say the word transversal a billion times in the next couple of days. Hey, if you need to like scoot your desk over and like angle it more or something so you can see, that's fine.
What's the DCF? Now be careful here. What's the DCF of the second group?
However y'all need to get situated so you can see better. I do not care.
You don't know the factors for 162 off the top of your head. I'm not expecting you to.
All right, a transversal is just a line. Okay? A transversal is a line that cuts through two lines. So if I have two lines, they don't have to be parallel to each other. So you see the two blue lines on the screen. Okay? Those are just two lines. Well, that red line cuts through both of those lines. Y'all see that? So a transversal is any line that cuts through two other lines. Like I said, the lines don't necessarily have to be parallel for the line that goes through them to be called a transversal. Okay, now in this unit, most of the time they will be parallel lines that are cut by a transversal, but the two lines don't have to be parallel lines. I do like that I can walk all over my place when my room's like this. Okay, so when I have two lines that have a transversal going through them, so I have three lines total, right? Right? Okay, then we have angle relationships that are formed. Draw this and write this down. There are four main types of angle relationships that are formed anytime two lines are cut with a transversal. The first pair of angle relationships are called corresponding angles. Corresponding angles. And draw the picture, because if you just have the definition without the picture, it's not going to make much sense when you're going back and looking at it.
Now we have four terms. How do we factor four terms? We group. There's the first two, leave the middle side, there's the last two.
And again, these lines are not necessarily parallel. We're just talking about relationships.
What's the second group? Negative 1 with lead. X plus 5y. Very good. Be careful with those signs. Do our parentheses match? Okay, so we can write two binomial factors.
So corresponding angles are angles that have corresponding positions when two lines are cut by a transversal. Corresponding angles have corresponding positions. Well, what does that mean, corresponding? They're kind of the same. They go with each other. Okay? If something corresponds to something else, that means it makes it happen, or it goes with something else, or a lot of times they look the same. Okay? So corresponding angles have corresponding positions. So they're in the same position. So here's my two lines. They're kind of horizontal. They're not really horizontal because these lines are not parallel. Transversal has the little T over it. That's how you know sometimes specifically if it's a transversal, if it has a T. Not always, but sometimes it will. Sometimes you're just supposed to know it's a transversal. But this is two lines, and we have a transversal T going through it. Angle 2 and angle 6 are on the same position of that transversal with those lines. They're both above the line and to the right side of it. Do you see that? They're in the same position. So those are what we call corresponding angles. Does that make sense? There's also a pair of corresponding angles on the other sides of them. You see that? Okay. And also, if you go down right here, these are corresponding angles as well. You see that? And same thing right here. These underneath are corresponding angles as well. Okay. So corresponding angles are in the same position of the transversal. Okay. They're in the same spot. This 2 is in the same spot as the 6 is. Does that make sense? Okay. So that's what corresponding angles are. All right, the next angle relationship that's formed between transversals are alternate interior angles. So I'm going to hush and let y'all write that down for a second. Alternate interior angles. That word says lie, in case you can't read it. It looks like something else. Oh. Alternate interior angles. What does the word interior mean? Inside. So if I'm talking about the interior of my car, I'm talking about the inside of my car, right? Which is messy, really messy. Got 2 kids. All right. So interior means inside. Alternate means kind of opposite, right? Alternate means opposite. So alternate interior angles are angles that are between the two lines in opposite positions of the transversal. Okay, this one is left and down the transversal. This one's up and right on the transversal. Y'all see that? They're between the two lines. That's what interior means. They're inside the two lines, and they're in alternate positions. So these two angles right here, even though those are not named, these are also alternate interior angles. Okay? So every time two lines are cut by a transversal, you're going to have two pairs of alternate interior angles inside the two lines in alternating positions. Does that make sense? Does everybody understand what alternate interior means? Inside the lines in opposite or alternating positions. Okay. Well, before I show you the picture, what do you think alternate exterior angles are going to do? They're going to be on the outside of the two lines in alternating positions. So like this angle 1 and angle 8 right here. They're on the outside of the two lines, and they're in alternating position. One's left and up, one is right and down. So that's alternate exterior angles. Exterior means outside. Interior means inside. Exterior means outside.
There are multiple versions of this test. If you try and look off of your neighbor, it will be very obvious. If your name is at the top of your paper, I want your work to be on your paper, not anybody else's. Okay? All right. Now, you can see.
Okay. Alternate exterior angles lie outside the two lines on opposite sides of the transversal. Bum, 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 bum. Y'all ready? There's one more. All right. Consecutive interior angles. Consecutive interior angles. Now, what does interior mean? Inside. And consecutive means one right after the other. Okay? So that means they're inside the angles, or inside the two lines. They're on the same side of the transversal, and they're one angle right after the other. Okay? So consecutive interior angles are going to be on the same side of the transversal. And they're between the two lines again. Interior means between the two lines. Exterior means outside the two lines.
It goes in the basket. Right in front of your basket, we have unit and vocabulary list that you need to start on with your list. Right? Any questions? All right, go ahead and begin. You have the whole class going. I'll stay till 11:29. So that you can turn in by the end of the class. Good deal?
All right, we good? So those are our four angle relationships that happen when any two lines are cut by a transversal. All right. Now,
And one more thing, there are
special things happen when the lines are parallel to each other. Okay, there are special things to note about those relationships. But first, let's just talk about these. Here's a picture. Okay, and you might want to draw this picture and label all the parts. Make sure you label the numbers. And we're going to list all of our corresponding angles, all of our alternate interior angles, all of our alternate exterior angles, and all of our consecutive interior angles. Okay? Y'all, knowing these angle relationships is the most important thing you can know about this unit. Gotta learn the relationships. So draw the picture on your page and make sure you label the number angles like I have labeled it. Now, I'm going to scroll down. I can write the other words later, but I'm going to have to be able to touch my picture. And I can't reach that high. I'm pretty tall, but I can't reach that high. Okay. Y'all have the picture drawn? It goes 1, 2, 3, 4, 5, 6, 7, 8. All right. So first we want to find all of our sets of corresponding angles. So go back to your notes. What does corresponding angles mean?
They have corresponding position.
They're in the same position, right? They look like they're in the same spot, but for another set of lines. All right. So let's just start with angle 1. What angle do you think corresponds? Stop. What angle do you think corresponds with angle 1? Corresponds. Well, these two lines, and here's my transversal, right? Which one is in the same position? Angle 5. Good. So angle 1 corresponds with angle 5. Miss Isabel, I've got to work on my handwriting on this thing because it's so touchy. All right. There's a lot more. Let's just go with angle 3. What corresponds with angle 3? Angle 7. Do y'all see how those are in the same? Angle 3 and angle 7. All right, let's just keep going. What about angle 2? Angle 2 goes with angle 6. Do y'all see what I'm doing? They're in the same spot. Angle 2 and angle 6. All right. Angle 4 and angle 8. And those are all my corresponding pairs. Y'all agree? 4 and angle 8. And they go both ways, right? Y'all understand what corresponding means? They're in the same position of the transversal. All right, number 2 says alternate interior angles. What does interior mean? Inside. So it means I'm only looking at the angles that are in between the two lines, right? So I can only possibly use 2, 4, 5, and 7, right? And alternate means they're in alternating positions. Okay? So what is the alternate interior angle that goes with angle 2? Angle 7, and then 4 and 5 go with each other. Y'all see that? Alternating positions. And interior means inside. So angle 2 and angle 5 and angle 4. I messed up, didn't I? Sorry. Angle 2 and angle 7 and angle 4 and angle 5. Okay. Everybody okay with alternate interior? After I fix my boo-boo. All right, alternate exterior. What does exterior mean? Outside. So I'm not looking at the inside angles. I'm looking at 1, 3, 6, and 8. And alternate means an alternating position. So which one is alternating exterior with angle 1? Angle 8. So angle 1 pairs with angle 8. And what pairs with angle 3? Angle 3 and angle 6. So okay with alternate exterior? Is that okay with everybody? Outside angles and their alternating positions. And the last one is consecutive interior. Okay, so interior means we're looking inside the line, so we're looking between them. All right. but consecutive means they're on the same side of the transversal. All right, so we're looking at angles 2, 4, 5, and 7. So with angle 2, which one is the consecutive interior angle that goes with angle 2? Angle 5. They're on top of the transversal, basically, right? And which one goes with angle 4? Angle 7. Okay. So the most important thing you can do in this unit is learn your relationships. All right, and y'all are off to a great start. Good job. Good job. Now these are on our handout. Okay, so you might want to get a highlighter and highlight some important words to go along these, because you're going to have to memorize these properties with these relationships. Okay, so find the corresponding angles postulate. It is the third postulate down on the front piece of the paper, the front page of the paper. The corresponding angles postulate says if two, what kind of lines? Parallel. So if the lines are parallel, do you see those little arrows on these two lines? You see those little extra arrows inside those two lines? That is showing you those are parallel. So anytime you see any extra arrows or little triangle looking things with the two lines, that means those lines are parallel to each other. Okay? So if two lines are parallel and they're cut by a transversal, then the pairs of corresponding angles are what? Congruent. Highlight the word congruent. Corresponding angles are congruent. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Highlight that word congruent. Corresponding angles are congruent. Memorize, memorize, memorize. Scrolling. Okay, an example. Y'all don't have to write this down, just do it with me up here. Can y'all see it? Do I need to zoom? Okay, identify all the angle measures whose measure is 120 degrees. So this angle, which would have been angle 1, is 120 degrees. Right? Right? I just said that all corresponding angles are congruent. Right? So what's another one that's 120 degrees? Angle 5. Why is 4 120 degrees? Because those are vertical angles. We can't forget about vertical angles, right? Right? Is there another one that's 120 degrees then? Angle 8 is 120 degrees. Y'all see that? So we can't forget vertical angles. We're going to use vertical angles a lot, even though we didn't learn about them this unit. We learned about them in Unit 1. They're still going to be popping up for us a lot. Okay? What if I wanted the measure of angle 2? Right, these are a linear pair, aren't they? Also known as supplementary, right? I'm up here with it. All right, so 180 minus 120 is 60, right? So what all angles are 60 degrees?
3, 2, 7, 6.
2, 3, 6, and 7. So basically, if you have two parallel lines and you'll see that little triangle showing that those are parallel, and you know one of the angles, then you pretty much know all of them if it's two parallel lines and one transversal, right? Right? If you know one of them, we can do the rest of them, right? Y'all see that? All right, good job. I'm going to unzoom it. Okay, good job, guys. All right, find the alternate interior angles theorem. Now, this one's a theorem, so it's a little bit down further on the page. So it's about 2/3 of the way down, maybe 3/4 of the way down. Highlight alternate interior angles theorem. And again, these are two parallel lines because they have those extra arrows right there. If two parallel lines are cut by a transversal, then pairs of alternate interior angles are what? Congruent. So corresponding angles are congruent and alternate interior angles are congruent. So highlight or circle the word congruent so that you know to memorize alternate interior angles are congruent. Corresponding angles are congruent. Alternate interior angles are congruent. Da 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 da. Alternate exterior angles. Is that the next one? Says theorem 3.2. Alternate exterior angles. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are what? Congruent. So corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. That's 3 out of our 4 relationships, right? Right? Okay. Last one. It's at the bottom of the page. Right? Are these congruent? No. Consecutive interior angles theorem. If two parallel lines are cut by a transversal, then pairs of consecutive interior angles are what? Supplementary. So alternate interiors are congruent, alternate exteriors are congruent, corresponding angles are congruent, but consecutive interior angles are supplementary. What does it mean to be supplementary? They add to be 90, not 90, 180 degrees, right? Okay, good job. So now we get to work some problems. So get your notebook paper out. We're going to do some examples. Draw this picture. Can y'all see it? That's one good thing about this touch screen is I can zoom when I want to. Here's an example. Are those lines parallel? Yes, they have the extra little arrows on them telling you that they are parallel. Some of you are not drawing my picture. This is your examples. You're going to have stuff like this on your worksheet in a little bit. That says 115 degrees. If you can't read it, this is just angle 4. It's not a degree measure. It's just calling it angle 4. Just giving it a name. So you treat it like a measure if it gives you a degree sign. If not, that's the name of the angle. Okay. So it's to find x. Right? Do we have enough information? Okay, first of all, x is down here for this angle. Does this angle and this 115 degree angle have a relationship? No, one's an interior, one's an exterior, but they're not corresponding, right? So they have no relationship, right? But what's this angle's measure with angle 4? They're going to be the same because these are what relationship happens between these two angles? They're vertical angles, right? So this one, angle 4, is 115 degrees. Y'all see that? And does angle 4 and this x plus 5 have a relationship? What's that relationship?
Consecutive interior.
They are interior angles and they're on the same side of the transversal, so they are consecutive interior angles, right? And we just learned that consecutive interior angles are what? Supplementary. So that means this plus this equals what? 180. And that's how we're going to solve for x. We're going to say 115 plus x plus 5. And you could have did that in the other order. Equals 100 and it's not writing half the time. I got to figure out this touch screen. I'll get there maybe in 10 years when it's time to get a new computer. So like terms, what's 115 plus 5? So x plus 120 equals 180. Now how do I solve for x? Get back. Come back. There we go. Subtract 120 and x equals what? 60 degrees. Now, it didn't say to find this angle, but what is this angle measure? 65. 60 plus 5 is 65, right? And if I add that with 115, it does equal 180. Good?
Wait, hold on. Would it be 60 degrees or not? Because if the degrees outside the proof.
If you leave the degrees off here when you're solving for x, I'm okay with it. I'm good with either one. Good question. All right, here's another one. Draw that picture, please. We're finding x again. That's all we're doing is finding x. It didn't say to find an angle measure, just find x. And this angle up here is 135 degrees, and this angle down here is x minus 30 degrees. Is there a relationship that exists between these two angles?
Yes.
What is that relationship?
They're corresponding.
They are corresponding angles. And what have we learned about corresponding angles? They are congruent. So how can I set up to solve for x?
X minus 30 is equal to 65.
Yep, just set them equal to each other. Very good. X minus 30 equals 135. Any questions about why I can set them equal to each other? They are corresponding angles, so they're congruent. So we can set their measures equal to each other. And so I add 30 on both sides. And x equals how much? 165. And I can check it. Is 165 minus 30 135? Yes. You'll see what we're doing? So you're either going to add the two angles if they're consecutive interiors, set them equal to 180 degrees, or if they're alternate interior, alternate exterior, or corresponding, you're going to set them equal to each other and solve for x. That's it. Okay? That's it. Yeah, here's y'all. You try. Yeah, this looks harder, but it's really not. Can y'all see it? There you go. Draw it, fill it in, and solve it. Couple ways you can approach this one, right? Help your people at your table out for a second if you need to. Start by filling them in. I'll leave you come say today. Mike said you could. So. Well, I'm just gonna say, I'm probably gonna send them a copy delivery soon. So. That way you can see a more accurate snapshot, it's not table detail. Okay, so based on these relationships, guys, mathematically, there's only two things that's gonna happen, right? You're either gonna set those angles equal to each other, or you're gonna add them together and set them equal to what? 180. That's the only two things that you're gonna do mathematically, right? One or the other. Set them equal to each other and solve for x, or you're gonna add them together and set them equal to 180 and then solve for x, right? Now, the way I approached it is I took this 68 degrees because it's easy to work with, right? And I filled in all my angles that were 68 degrees. That's what I did. Does that make sense? Yes, sir.
Can you just subtract 68 by 180 since I have 3 and 4 are 80 degrees, so 5 and 4 since.
Yes, you can. Yes, you can. Yes, you can. Good job. Good thinking. See, that's a different approach. Like I said, there's multiple approaches, and I'm just going to show you mine. Okay? But that's a really good approach, Nick. Good job. All right. Y'all see what he said?
Yes.
He said that it makes a linear pair with angle 4. So if you subtract from 180 and you get angle 4, those are corresponding angles, so you can set them equal to each other. Is that what you did? See, that's perfect. That will work 100%. Good job. What I did is I just took my 68 degrees and copied 68 degrees everywhere I thought that the angle was 68 degrees. All right? So I did, well, angle 2 is 68 degrees, right? And then it's a corresponding angle with angle 6. And that one's 68 degrees, vertical angle with that, 68 degrees. And those are linear pairs. So that's how I'm going to add those together and set them equal from 180, right? So it's the same thing that he did. It's just thinking about a different way. Okay? Does anybody have something different, a different way that they thought about it? Did y'all do it one of our two ways? Okay, good. Good job. So I'm going to do it 2x plus 4 plus 68. Oops, I forgot my 4, didn't I? 2x plus 4 plus 68 equals 180 degrees. Those are like terms, right? So that's going to be 2x plus what? 72 equals 180. Subtract from subtract 72. I can't even speak. So 2x equals what? What's 180 minus 72? 108. And then you divide by 2. And x equals what? 54. Raise your hand if you got x equals 54 for your x. Any questions? Any questions? Good job. All right. Find the Find the corresponding angles converse on your handout. So you can highlight it instead of writing it. Now, reading that, it's like 2/3, it's the fourth one, right? Postulate 16. So highlight it. And it's a converse theorem, or postulate, right? Y'all remember what a converse does? What's a converse statement do? It reverses the hypothesis and conclusion, right? So it being a converse statement, that means it's the converse of the corresponding angles postulate. And the corresponding angles postulate said If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. The converse says if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. Y'all see the difference? Right? So the first one tells you that parallel lines by a transversal corresponding angles are congruent. This one says if their angles are congruent, then the lines are parallel. So you're going to use the converse postulates and theorems to prove that the lines are parallel. Does that make sense? So this example right here, you don't even have to copy it, just watch with me, please. It says find the value of x that makes M parallel to N. Okay, that's how we show parallels, two straight lines. Okay, well, they're not exactly straight. They can be vertical or slanted. Okay, so two lines means parallel. So find the value of x that makes M parallel to N. Well, those are corresponding angles, right? Right? So I set them equal to each other to find what x would be to make them equal to each other. And then that itself proves that the lines are parallel. Does that make sense? So it's just like working it the same. You're doing the same thing. You're just, this time, they're not telling you the lines are parallel. You're proving they're parallel. Does that make sense? Y'all see the difference? But it's the same thing. 3x plus 5 equals 65. Subtract 5. 3x equals 60. Divide by 3. And x equals what? 20. Okay? Does that make sense? All right. Just a few more converses. Find the alternate interior angles converse. It's on the back, on the very top. So basically that says if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. Okay? So that's all you're doing with these converse theorems are it's showing that they are parallel. So the alternate exterior angles converse, highlight that one as well. If two lines are cut by a transversal and alternate exterior angles are congruent, then the lines are parallel. And then go ahead and do consecutive. But these are not going to be congruent, aren't they? Consecutive angles are what?
Supplementary.
Supplementary. So if two lines are cut by a transversal, so consecutive interior angles are supplementary, then the lines are parallel. Okay? So you're going to use converse theorem to show that they are parallel. Got it? All right. That is the end of notes for today. We're about to have a worksheet for practice. Have a good day.